Well, good morning, everyone. It's really wonderful to be here, and thank you, LJ, for just reminding me that 5 years is a very difficult time frame to make any kind of predictions. But I would really like to start with a very, very warm welcome, Secretary General, to all of the leaders from government and industry, academia, civil society, UN organizations, and of course, all of the scientists, all of the founders, all of the private sector. Everyone here will play a crucial role in shaping this future, and this is an extraordinary gathering. And I think testament that this has been going on since 2017, so somebody did have a very good crystal ball way back then. When I was preparing for this talk, looking out to 2030, I was sitting in my office, which is in my back garden, and I looked out of the window and I could see the fence, and there's one fence panel that is dilapidated. It's flapping in the wind, it's under the weight of ivy. It really looks like it'll collapse at any moment. It's looked like that for more than 5 years. Back in 2019, in fact, before the COVID pandemic, I had said to myself, I must replace this fence, and I just haven't got round to it. But in that 5 years, we have seen real strides in technology, in AI, in renewables. We fought off a global pandemic with new vaccines, with new methods, new approaches. So 5 years, not long enough for me to fix a fence, but certainly you can see some progress in the world. But one question I think we really need to ask ourselves is, can we see the impact of AI in our daily lives at scale yet? Will AI's impact in the next few years be significant? Why would those next years be different? And what should we do to get the most out of them? So if we think a little bit about where we have come from over the past few years, the economist Robert Solow said of the computing age back in 1987, he said, you can see the computing age everywhere but in the productivity statistics. Now, when I look at the AI world, I think the same thing seems to be true today. We can see AI everywhere except in the productivity statistics. We can see AI everywhere except in getting ahead of the SDG targets, getting ahead of carbon emissions. Go back a few years, 2017, we were promised autonomous vehicles everywhere in our streets, roughly by about now. Even though I'm involved in this area, I've only spent 25 minutes in an autonomous vehicle in the last decade. We were told that medical AI would be improving patient outcomes. We were told that we wouldn't need radiologists anymore. We get to 2024, and in the US, there are more radiologists than ever, and there's a shortage of radiologists in the US, shortages that will be compounded as we go across the globe to emerging economies. And let's tackle that question of productivity and the economic impact. Well, go to the US, again, the most advanced economy when it comes to AI. Productivity growth between 2019 and today has been roughly 1.5% per annum. That is a smidgen above the dark days of the 1970s of oil crises and of stagflation. So perhaps we aren't yet seeing AI show up in the statistics. But a lot can happen in that 5 years. If we look at the world of renewables, the amount of solar electricity capacity we have has tripled just in those past 5 years. Incredible strides in China, for example, in changing their energy system, and now in India as well. The cost of batteries in electric vehicles has declined by 40, 50, 60% in that period of time. And to the point that 1 in 5 of all cars sold globally is now an electric vehicle. Going back to China, it's 1/2 of all cars that are sold that are electric vehicles. And if we look at other technologies that really matter for human welfare, take genome sequencing. Well, back in 2019, it cost about $1,000 to sequence a human genome. Today, that price is around $100. So there's clearly something going on in that 5-year period. And the reason for that is that these technologies are exponential technologies. So exponential technologies are technologies that get better and better or cheaper and cheaper on a compounding basis year after year. They, at some point, hit a tipping point. They hit a tipping point where they're just good enough or they're just cheap enough for businesses, for governments, for consumers to want to use them. And we hit those tipping points in things like solar and things like lithium-ion batteries for electric vehicles in the past few years. And we're familiar with lots of exponential technologies. The original one, the OG, is computing, and the microchip, and the famous story that your typical smartphone is more powerful than all the computers in the world when the Apollo 11 landed on the moon in 1969. But when we think about AI, the question is, where is that tipping point? And I think one tipping point that we hit has been with large language models, or LLMs as I'll refer to them. So GPT-2 was made available in 2019, and I think it was the first time that the wider technology community, the developers rather than the AI specialists, started to think this is a technology we can do useful things with. And what's happened in those 5 years? Well, go forward 5 years, and we've seen incredible improvements in the capabilities of these large language models. We've seen the cost to use them for the end user decline significantly, and hundreds of millions of us now use large language models as consumers or at work, and it's become the fastest adopted enterprise technology ever. And the reason is, it's unreliable, sure, we know that. We'll hear about that, I'm sure, later in the next couple of days. But as a technology, it is just good enough for just enough of us. And so even though there are many, many improvements to come, don't let anyone tell you that GPT-4 is as good as it will ever get, that there aren't new technical approaches that we will use over the coming years and decades. LLMs will be the backbone of the systems used in enterprises for the next decade or so. And of course, AI extends far beyond generative AI. AlphaFold has helped us discover protein structures 1,000,000% faster than humans, augmenting our capabilities, and there are AI systems being used by scientists to develop new catalysts. There are systems being used to improve battery performance or to optimize the use of energy in data centers. Once you have technologies that are good enough and cheap enough, they go past that particular threshold. You can see rapid and widespread diffusion. You go from a very quick shift from the old methods, old tools and practices, to new tools and practices. This happens even with big physical clunky technologies. So if you look at the transatlantic passenger route from Europe to the United States at the turn of the 20th century, it was dominated by steamships, but it only took 15 years for that route to be replaced by, it was dominated by sailing ships, and it only took 15 years for that route to be replaced by steamships, and that grew the market significantly. It didn't even matter that there was a human catastrophe in 1912 with the sinking of the Titanic. The market continued to grow, the transition happened. We've of course seen that happen with smartphones. In 2012, 1 in 3 smartphones sold were smartphones. By 2017, it was 86%. Last year, 9 out of 10 phones sold in India were smartphones. 5 years earlier, it was about half. And so we can see that new innovations can make their way into our lives in unprecedented pace. We delivered COVID vaccines from discovering there was such a thing as COVID, although we didn't call it that when it started, to developing multiple vaccines, to putting it in over 5 billion arms in just a few years. And it was enabled by digital infrastructure, from supply chains to logistics, databases, and simple things like SMS alerts. And even in the case of the ITU, we saw very, very fast transitions as new telecoms technologies were developed over the past 160 years. And that's also another important point to bear in mind, which is that the technologies themselves don't stand still. The ITU was founded 160 years ago last year, and we haven't stopped improving the technologies for transmitting data at a distance. Earlier this year, Japanese and British scientists showed off a 301 terabits per second data transmission over a single optical fiber. So how can we play our understanding of exponentials and rapid transitions forward? How can we look at what's happening with AI and say, can we imagine a scenario where small-scale experiments become large-scale impact? Well, I think we have to do that. We have to, in some sense, look at those early minor signals. And those early signals are good. I'll pull out a few examples, but there are so many more that you will hear about over the next 2 days. Just take mine and remember there'll be much more to come. For example, in Ghana, I was tracking a chatbot service called Rory, which helps kids in pre-teens with their maths. And it's very, very early days. It's 1,000 students, but they are showing that a chatbot provided maths tutor will improve maths outcomes. And Sewer Code is another project that's tackling coding skills in 42 African countries, and it has a 3 times higher completion rate than traditional approaches. We do have some data about technology improving these types of educational outcomes because we can see that where communities have access to mobile phones and lower access to education, you see a significant uplift in educational outcomes. And what we have to hope, what we can believe, is that adding AI-based tools to that mix will see similar types of results. I'm also quite fond of a company called Atlas AI, which is building a geospatial foundation model. So in this model, they are mapping every part of the Earth around where humans live, the most remote communities as well as those closer to bigger cities, mapping them in terms of population, wealth, access to infrastructure. And so it becomes a living map for having targeted interventions. In Tanzania, an energy company used data from Atlas AI to identify 75,000 households who could benefit from solar-powered electricity. And in many parts of the world, there are hundreds of languages that are still alive and living, Indonesia being an example, of course, the continents of Africa, even small countries like Singapore. And here, the ability for multilingual LLMs to step in to improve educational outcomes, but also improve the delivery of services to people in their native tongue and increase economic opportunities for businesses is pretty significant. We've got startups doing that, as well as the big labs like Cohere and Meta. But when you think about AI, the thing we also have to hold in our heads is that it's an incredibly general technology. And so it's very hard to break off single uses and say, well, this is where it will actually work. And so the way that I think about this is that AI is fundamentally a technology that, for the next few years, can augment human skills. Now, some colleagues of mine at the consultancy BCG and at Harvard Business School ran an amazing study. And in this study, they took these strategy consultants, these knowledge workers, and they gave half of them access to GPT-4, and the other half were just working with their own brain cells. And those with GPT-4 completed tasks about 25% faster than those who didn't. But the quality had rose by about 40%. And it was pretty remarkable as a result goes. So in some sense, the way to think about this is that AI can give us superpowers. It becomes a skill-enhancing technology. It expands human capital. The interesting thing about the HBS results, which is one that has been, we've seen similar results with other experiments, is that the technology seems to be skill equalizing. That is, it improves those in the bottom half of the distribution more than it improves those at the top half. And that is an incredibly rosy outcome because every single one of us is bad at something. So I'm quite pleased at this idea that I will get lifted up for all of those skills that I haven't quite mastered. In the global south, this has huge potential because there you tend to have lower levels of human capital. And human capital depends on knowledge-intensive professions, whether it's education or whether it's teaching and healthcare. Being able to expand the capacity of the existing professionals in those spaces could see us develop human capital more robustly than we have in the past. Now, of course, an AI-augmented human or an AI coach on its own will never be perfect. But at this point, we should recognize that the best can be the enemy of the good. The Pareto principle is quite powerful. 80% is sometimes good enough. So AI can give us superpowers. It offers us a chance to improve at things we're not necessarily great at. But the question is this really how AI is going to be developed? I mean, we have to think about whether companies will look at this technology as a way of upskilling, augmenting, powering up their workers, or as a way of driving down costs and improving efficiencies. And if it's the latter, it's that old battle of capital versus labor once again. Now, at this point, maybe we should take off our rose-tinted glasses, and maybe we should assume that without any steering, the market will choose a path of efficiency, that short-termism will be more alluring. And given that the technology will roll out very quickly, what can policymakers do to maximize the chance that it will be done so beneficially? So I think there are three things. So the first is that we need to ensure that technology can augment and expand human capacities. And we don't start, if I'm frank, in some parts of the world from a very good place. The consultants Edelman do a survey of trust in technology every year, and in 15 out of 28 richer countries, citizens are negative about the prospects of AI. By the way, the reverse is true in the global south and in emerging economies. But this is a warning to firms and policymakers that we haven't brought people with us. Our narratives have not been reasoned, defensible, and constructive. They have been hyperbolic or extremely skeptical. So what we need to do is we have to bring our narratives back to a place of greater reason and consideration and find the policies that we need for augmentation. Now, it's not just about engaging with workers and providing training, education, and upskilling. Those are the hygiene factors. It's really about creating the economic conditions that favor augmentation. And that means they favor growth, they favor entrepreneurship, the creation of new human and human-augmented tasks. The second thing we have to keep a handle on is how we create a diverse and competitive and transparent AI sector. This is a technology that tends to winner-take-all, and the rewards are so high, there is quite the unseemly land grab going on at the moment. We're seeing firms trying to get monopolistic positions, dominant positions, and engage in some of the most regulatory capture that historians have ever seen, and in the process, cut corners in the name of progress. AI is going to be the infrastructure of the 21st century, and we stand at the 21st century with the benefits of history, being able to look at some of the commercial dynamics that emerged as railways expanded across the United States in the 19th century, and as the oil industry grew at the start of the 20th. So governments need to invest in the impact of these technologies, and some are doing so already. For example, in the UK, I'll fly my home flag for a second. The AI Safety Institute is building empirically robust tech tools for evaluating the safety of large models, and the Competition Authority is asking some challenging questions about emerging market dominance. So ultimately, we have to understand what those commercial land grabs look like and figure out what kind of innovative interventions, public-private partnerships, capability building, and new rules we can use to guide the technology. And the final thing, which is really a message for those of us here who are leaders of people, this is my imagination of what the inside of an LLM is like, by the way, lots of kind of books and some machinery. You need to have deep, visceral, intuitive knowledge of the tools and how they work at this point. At some point in the future, in the next decade or so, leaders like you will not need to be hands-on because we will know how this technology works. Today, we don't. So I do encourage people to, in their domain, in an area that they care about, spend time, 8 hours, 10 hours, going deep, using these tools for something you care about to understand their strengths and limitations and surprises. So whatever vision and direction you come out with is not theoretical, it's grounded in your own experience. So the next 5 to 6 years, we will see that acceleration along the AI curve. And what will determine where we end up in 2030 and what that world looks like will be the institutional response and what we do to make sure that AI gives us and gives workers, gives people superpowers rather than seen as a tool of replacing them. And it's gatherings like this that will help us shape that future. Now, as to whether that's going to help me fix my fence by 2030, I think we're going to need a completely different technological revolution for that. Thank you very much.